My pleasure once again to come into the modern world, and this will be the third webinar that Suffolk Horse Society. And can I thank Andy, Dr. Andy Dell, for giving up his time this evening. He's going to give us a presentation on sparks and the closed. Now, what's the official title, Andy? You're going to have to. I've lost my bit. Working within a closed stud book. So I know there'll be lots of questions. I think you're going to open it up sort of a couple of times during the presentation.
I think that's probably the best thing. There are a few logical places where we can just pause, take a breath, let people ask some questions, listen to someone's voice apart from mine, and then we can dive into the next logical section once we tidied some questions up. So yeah, more than happy.
Brilliant.
Probably the best thing to do is to take questions at third the way through, 2/3, and then we'll have a more open discussion at the end probably.
Lovely, thank you, Andy. So, and I see everybody is muted, so let's, if we can all mute to save the dogs and everything else, and then during that point we'll put hands up when Andy opens it up and go from there. But I'll hand over with thanks to Andy to give us a presentation.
Evening, folks, and yeah, thanks for the invitation into your homes. As Mark said, he's done a bit of the housekeeping. I'm sure you know where your loos and your kettle are, but yes, if you can mute, then that will save us getting howl round from dogs and small children. I'm going to keep my headphones and my microphone on. I don't normally like giving a presentation like this, but I think it'll help improve the audio quality for you. So what I'll do with a click of the button, hopefully, is to share my screen, and we'll make a start. And if I go into presentation mode, we should be there. You might find it easier if you've got pictures up on the side of the screen here. If you drag them down to the bottom, then you'll be able to see a lot more of the screen. Okay.
You can't be too technical with me, Mr. Dell. I'm not very technical at this sort of thing.
Do what I did and stick the arrow on. You can move this bit around, you see. If you just grab hold of it and stick it down the bottom, then when there's writing appearing over on this side of the screen, you'll get on a lot better. And somebody's waiting for Fred to come in, so I press that magic button. That should let him in. Yes, closed stud books have a lot of problems, but the Suffolk horse and the breed that's close to my heart, the Cleveland Bay, share very, very similar problems. And this evening, a lot of you who were at Rosdale's just over a year ago now, when I gave the presentation with Ruth Dalton, will notice that I put up a lot of Cleveland Bay pictures. And there's a reason for that, and that is because over the years I've learned that if I put up pictures that I don't know the true origin of, you suddenly get people saying, oh, that was my picture and that's my Suffolk horse and you didn't have permission, or why didn't you show mine? So I'm going to try and steer away from pictures of Suffolk horses tonight, and I'll put up Cleveland Bay pictures because they've got 4 legs, 2 ears, a tail, they wag around at the appropriate time, and they share a lot of common problems. Okay, so a little bit about my background for those of you, if I just let Fred in there, those of you who haven't met me before. I just ignore the Middlesex accent. I was brought up down in Devon. I grew up with horses, and I moved up to Cumbria, where I've lived on this small holding with my partner Jill for best part of 30 years now. And the love of our lives has been Cleveland Bay horses, keeping them and breeding them. And you can almost ignore the title, the academic title, Dr. Andy Dell, because I did things the hard way round, and that was to be a horse breeder first, and academia came to me later on. And it's only in the last 10 years that I've waved that doctor title in front, when Lincoln University came to me to get me to write up what I'd been doing with the Cleveland Bay Horse Society and breed management of Cleveland Bays. So that's pretty much the background to how we got to where we are now. What I want to talk about tonight, and yes, there is a picture of a Suffolk horse. I want to talk about the problems that we share because we breed to a closed stud book. I want to have a look at how the Suffolk horse is doing compared to some other equine breeds, both at home and abroad. And to talk about breed management strategies that have been developed to help deal with the problems that are inherent. If you invent a breed, you draw a ring fence around it, you close the gates, you say you're not going to allow anything else in. So in other words, you've got a fixed genetic pool, and then you breed from it generation after generation after generation. And when we've done that, towards the end, hopefully we can look at how we can monitor the breed and secure it into the future, which is something that's dear to our heart. I don't know what your philosophy is. I know Mark shares the same philosophy. That is, there's no point in going out inventing a wheel if there's a perfectly good one already. And when Jill and I first started breeding Cleveland Bays and realizing how closely related they were, and when our kitchen table didn't get big enough to spread stud books out and pieces of A4 paper, I went, hang on a minute, what do people do with really rare animals? And at that time, I was under the impression, like a lot of the world, that probably one of the rarest animals around was the giant panda, but also other things like white rhinos, Siberian tigers. So I looked, and my background as a biology teacher made me investigate, how do they manage those breeds? And in fact, the captive wildlife world has been way ahead of the livestock world, partly because of funding from the Walt Disney Foundation. And they are probably 20 or 25 years ahead in developing strategies for dealing with these tiny genetic pools and stopping the problems that, that come with them. So a lot of the science that I'm going to talk about tonight owes its foundation to Walt Disney and work that went on at Chicago Zoological Society, Lincoln Park Zoo. And words that you're going to hear quite a bit are inbreeding, and we'll just have a little look in a little bit more detail about what we understand by inbreeding, so we understand and we're talking about the same thing. Following on from that, I want to develop the idea of mean kinship and what that is. It's closely related to inbreeding, but it's something that sometimes gets ignored to the detriment of the breed. And then I want to talk about something called effective population size, which to an individual breeder probably isn't of that much interest, but as a breed society it should be, and as a government it definitely is. And in fact, the Food and Agricultural Organization of the United Nations have said that is how they determine how successful governments are at maintaining their biodiversity, be that wild animals or livestock. So, small populations, be they Eriskay ponies that I've done quite a lot of work with, Cleveland Bays, Suffolk horses, whatever it is, if you've got a small population, it is going to lose diversity, and it is going to lose diversity at a much faster rate than a large population, even if that large population is ring-fenced. And the reason for that is genetic drift, and in a moment I'm going to explain in fairly simple terms what genetic drift is, so that you can understand in terms of the Suffolk horse what's going on at the moment. And then I want to talk about inbreeding, but in particular about inbreeding depression and what that actually does to a breed, because it's quite important if we're thinking about where our breeds are going to be in 10, 15, 20 years time, more importantly in 1 or 2 generations time, because very much in livestock breeding we need to think not about years but in generations. And for most horse breeds, Suffolk horse, Cleveland Bay horse, certainly the average generation interval is about 9 years. And tied in with this concept of inbreeding depression is another thing that I need to explain, and that is accumulation of deleterious traits and loss of fitness. So those are all problems that I'm going to talk about and explain in a little bit more detail. And all of those problems contribute to this thing called the extinction vortex. And this diagram's been touted about quite a lot in recent years, but it's worth just reminding ourselves that if we start off up here with a small population, and I think we can definitely consider anything that's on the RBST watch list as a small population, it's going to suffer from inbreeding. As a consequence of that, it will be undergoing genetic drift. And through that process, genetic diversity will be lost. That loss of diversity leads to a restriction in fitness, and I can explain in a little bit more detail what we mean by fitness and the ability of a population to cope with changes it faces. That in turn, as we carry on down this spiral, leads to a lower reproductive rate. It's harder and harder to get these mares in foal and keep them in foal and take them to full term. We've got a higher mortality, and whether those foals are being lost in the embryonic stage or in those first hard 6 months of life, it depends. But you can see what happens. We've come all the way around the spiral and we get back to the same place, but it's not the same place because we've got an even smaller population. So you can end up, if you're not careful, on this downward spiral that's commonly called the extinction vortex. And that is something that every rare breed needs to try to step off of or stay off of that downward trend. So, genetic diversity, what does it actually mean? Not just for our rare breeds, but for everybody. And if we put it in a human context, you've got all sorts of DNA going on inside you. It's your genetic makeup. And for most mammals, we inherit pairs of genes. Part of that comes from our mother and part comes from our father. In the horse world, some of it comes from the sire, some from the dam, in equal amounts. And if you consider those genes as coloured Smarties or coloured marbles, and you put them in a big heap, for a horse, that heap would be 2.7 billion marbles big, but they wouldn't all be the same. And if you could sift through them and sort them out in their colours, in this diagram, we've got an awful lot of one type. At the top of the heap, we've got the red ones, and then going out, the less frequent ones, we've got the purple Smarties and the yellow Smarties, and then out towards the edges of the heap, there are blue Smarties, which are the ones that everybody wants, and the green Smarties. So our genes come in all sorts of different proportions and ratios, and that's pretty much the same for all mammals. Okay, let's go back to our very traditional concept of pink for a girl and blue for a boy. And let's take two completely unrelated parents. That in livestock breeding is quite hard to do, because if you step right back to the start of a stud book where you've drawn a line in the sand and you said, right, this is where the breed was created, it's highly unlikely that all of the founders were genetically completely unrelated. In fact, if we go right back to the domestication of horses, we know that all of the domestic horses in the world were descended from 85 different females. That's how closely related horses are. But of course, I'm talking of going back thousands of generations. But if we go back to what we notionally call in our stud book unrelated animals, and as I said, for each of those 2.7 billion genes that a horse carries, it's carrying 2 copies of a gene. So pink for a girl, this dam is carrying A and B, and over on this side, the sire is carrying C and D. Now let's do some animal breeding, and let's do a first cross, and lo and behold, we get a nice filly foal. And that filly foal, for this particular gene, has inherited A, that must have come from the dam, and it's inherited D, that must have come from the sire. Okay, so we take the mare back at foal heat, we get her back in foal again to the same sire. And in the next year, we get a colt foal. And this colt foal, at the same gene, is carrying B, inherited that from the dam look, and D, it inherited that from the sire. So in the next generation, these two being full siblings, we've now got A, we've got B, we can't find C, it's not there, and we've got 2 copies of D. So we've lost the allele numbers, the allele C, we've lost it in 1 generation. So that was lost because of genetic drift. There's nothing you can do about it. There's very little you can do to control which specific genes you lose without some very careful manipulation. But that's the problem. That's basic genetic drift, and it goes on irrespective of what you do. And at a population level, if we had a population to begin with that at that gene had 10 different variants. So we got 10 different coloured Smarties. We breed for several generations, and after several generations, purely by random sampling, we've only got 6 different colours left. And if we carry on for another few more generations, you can see what's happened to the whole population is we've now only got 2 different variants, of which red is really common in the population and blue is well underrepresented, and we've lost all of the other variants. So that's genetic drift at a population level. And that leads to something I mentioned before, which is inbreeding depression. It leads to a loss of fertility, which is tied in with inbreeding depression. And part of that is because lethal traits that we didn't necessarily understand very well before, things like the embryo dying in the womb, that actually just appears as a loss of fertility. So we can get a loss of viability of stallion semen. The stallions become less fertile. The mares are harder to get in foal in the first place. And then even if you do get an embryo formed, that embryo can actually die and be reabsorbed. So we get this general reduction in fitness in the population. And above all, there's this increased chance of what we call deleterious alleles being expressed. The other thing that happens is animals become more and more homozygous. And I want to go on a bit of a diversion here. When I spoke last time in Newmarket, I didn't put these slides up, but I think it's worth it, because as we register new foals, up until the demise of the Animal Health Trust, certainly for Cleveland Bays, all of our hair samples went off there for parentage verification. But I know that the Cleveland Bay Horse Society doesn't publicise or even make available to the individual breeder the results of parentage testing. So very few breeders have actually seen them. When it comes back from the Animal Health Trust or Weatherby's, whatever lab you're using now, this is the sort of report that comes back saying that it's parentage tested. Well, what does that actually mean? Well, at the moment, most equines are parentage tested by something called microsatellite analysis, and it's looking at 17 different genes out of those 2.7 billion that I talked about, and each of those has different alleles. So we've got VHL20 is one of the markers they're looking at, HTG4, HT4, and so forth. That report is quite hard to look at in that form. So what I've done is I've just tabulated it. So these are the approved markers down this side, the panel of markers they're looking at. And from the historic record, we know that the sire from his DNA testing was carrying 2 alleles at VHL20. He was carrying I and M. He was carrying K and M at HTG4. The dam was carrying IP here, K and M. So when they cross to produce the progeny that I've listed in the middle, the progeny at that particular marker has come back. The report says it's carrying M and it's carrying P. So where could they have come from? Well, that M must have been inherited from the sire there, look. And the P could only have been inherited from the dam. But that means that at that marker, this could well have been correct. These could have been the parents. If we carry on down, interestingly, at the next one, at HTG4, the progeny has got MM. He's got 2 copies of the same gene, effectively, the same allele at the gene. And where did he get them from? Well, one of them came from the sire and one came from the dam. And if you carry 2 copies, you're said to be homozygous. And working on down, if you look down through, you can see we're homozygous here because we've inherited a copy of K from the sire and a copy of K from the dam. But right the way down through, this is correct. We've got the right allocation, and these were indeed the 2 genuine parents, and it's proven, it's parentage verified. And that's the sort of thing that the society wants before it can issue a passport, because we know the chances of that being wrong is something like 2.7 billion to 1. So that is a correct breeding. It was reported correctly. Sometimes it doesn't quite work out right. Here we've got a very similar report, but instead of saying parentage tested or parentage verified, This is now saying DNA excluded. And this is where the stallion had jumped over the hedge. This is a genuine report, but as you can see, I've blacked out anything that can identify the horses involved. And to make it easier to understand, I've put it in the same table again. So this progeny at the first marker is N and P. So N, yep, it could have inherited N from the sire. It could have inherited it from the dam. But where did it get P from? It certainly didn't get P from either of these parents. If we carry on down, it's K and M. Could that have happened? Yeah, K could have come from the dam. M could easily have come from the sire. JJ, hang on a minute. Could have got J from the sire, but it couldn't get the other copy of J from the dam. This is looking really bad. If we carry on down, there are a whole host of things here that are not right. So these were not the two parents of this animal. If you look down here, FF, well, we've got F could have come from the dam here. There's no F here to have. So that's how we can say that the progeny was not by these parents. But that wasn't the real reason I wanted to talk you through this process. This was the real reason. This is from a genuine, highly inbred mating. And where I mean highly inbred mating, this mating was up in the 30%. When you think of a brother-sister mating or full sibling mating is 25%. This was horrendously inbred. And again, to make things easy, I've taken these results and put them into a same table for you. And in fact, these were the parents. If you run down through that test, it does work. But that's not what I wanted to show you. What I wanted to show you was, if you count down through here, this sire was homozygous at 1, 2, 3, 4, 5 sites, and the dam was homozygous at 1, 2, have I missed any more? 1, 2, 3 sites, okay? If you look at the progeny and count down through, what's happened is it's homozygous at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sites. That is a huge loss of diversity. All the potential genes, even those these were quite compromised to begin with, there's very few genes have been passed into the next generation. We've got multiple copies of very few. If you think back to that sample we had before of all those red Smarties in a dish, we're heading rapidly towards only red Smarties in the dish. So whereas the sire was homozygous for 5 markers, I think we did a quick count, was it 4 or 5 for the dam? This is homozygous for 12 markers. And that's only counting the 17 or so markers we tested. What else is going on with the other, what's left over from the 2.7 billion genes that aren't described by this table? That same process will be going on. So we're throwing a huge amount of diversity down the bath plug in one generation, simply by inbreeding. So let's try and understand what we actually mean by inbreeding. And at a simplistic level, an individual's inbred if its parents, if its mother and father share a common ancestor. And that just might mean it's at a cousin level. In other words, it's recent in the pedigree, or it might be back at the start of the stud book, 30 generations ago, or it might be back in prehistory. So inbreeding can accumulate very quickly, and it can accumulate over time from historic generations. But even if it's acquired from historic generations, what's happening is genes are tracking through the pedigree, and it could well be that the same gene is being inherited down the mother's side of the pedigree and the father's side of the pedigree, from down the mare side and down the sire side. But basically, it's a gene, an allele that's identical by descent. So it's descended through the pedigree, and you've got the same copy coming down both sides of the pedigree. So if we look here, go back to that original diagram, we've got unrelated dam and unrelated sire. If they cross, you've got unrelated offspring. But then if these offspring cross, they are then inbred. So in a first generation cross of unrelated offspring, we haven't got any inbreeding. But if you then mate those offspring from that generation, we will start to accumulate inbreeding. And as we said, that reduces gene diversity. I've just shown you how that happens through a genuine parentage test. It reduces fitness. It increases the chance of these deleterious alleles being expressed. And I've talked about the fact that inbreeding might be recent, or it might be very, very deep in the pedigree. So deleterious alleles, what are they? I think to put them in the horse context, they are genes that are what we call recessive, and they'd only express themselves if you pick up 2 copies of them. And to give you a real life example, the lethal foal syndrome that has been raising its head in, particularly in fells, but now in dales as well, has been attributed to a deleterious allele. So let's suppose we've got 2 unrelated animals. The mare's still carrying A and B, but instead of carrying C and D, the sire is carrying C and X, where X is a dangerous gene, but it's masked, it's recessive. So it isn't expressing itself. It doesn't cause a problem because it's masked by C being here. If we do a cross, the same crosses that we did before, this animal has inherited A from the dam, it's inherited X from the sire, and although it's carrying this deleterious allele, it isn't expressed because it's masked by A. Same thing's happening over here in the colt foal. It's inherited X from the sire, but it's also inherited B from the dam, and it's masked. Now if we breed in this generation and we cross these 2, what's happened over here is X has been inherited from here, B's been inherited from here, and it's masked because it's got B. But what happens if you pick up 2 copies of X, which is what's happened here? Suddenly, in the case of fell ponies, you've got lethal foal syndrome rearing its head. I'll just let that person in. So that is a very simplistic trait, and it's only it's caused by one deleterious gene, and not all problems, things like osteochondrosis dissecans, for example, and wobbler syndrome, those things are much more complicated. They're caused by multiple gene effects, but at a simplistic level, we can get these deleterious alleles causing these fatal problems. And I was reading a paper the other day that said, believe it or not, amongst the 2.7 billion genes, they've now identified 47,000 potential lethal traits in equines. So that's an awful lot of potential problems down the road as populations become more inbred. Suffolk horse. This some of you might recognize because it hails from Susan Blott. It was a study in 2009. And yes, she looked at what was going on in the American Suffolk population and in our population. I think possibly the Americans have digitized their stud book and gone back further than you have. I know your stud book, electronic at the moment, only goes back to 1930. But anyway, the data set that she had, she's managed to analyse the UK and Ireland Suffolk horse population from the 1960s. And what you can see is this trend. This green line is the one we're interested in. And if you look at that, you can see this trend of massive accumulation of inbreeding. And in fact, I can tell you now that it's gone through the magic 10%. We'll talk in a bit more detail where it might be right now. But in 2009, it was rapidly approaching that. I think when I spoke to you the first time, I didn't look in any detail at what had been going on in America. But you can see that in the 1940s to 1970s, they had a similar increase in inbreeding going on over there. Interestingly, in a closed stud book, for a population, inbreeding shouldn't go backwards. That's worth a look at in a bit more detail about how did that inbreeding reduce there and what's been going on more recently. And my suspicion is that perhaps they've opened the gate to the stud book a bit and other things have come in, or they've got a grading up scheme going on. And I've been asked over the last 2 years probably about, is there scope for American horses to be, or semen from American horses to be re-imported into the UK as one of the answers to controlling inbreeding. And I think we just need to be a little bit cautious, because this might be a bit of a telltale about have they actually maintained a closed stud book. Anyway, moving on before I go into political grey water. What about other breeds? And some of this data is quite historic now, but you can see that typically 10% isn't out of the norm. Thoroughbreds up at about 12.5% now. But I can tell you in a little bit more detail, certainly about Cleveland Bay horses, because of the studies that I've done. And we're not talking about 10s and 12%, we're talking about 22%. And look at that massive rate of increase in inbreeding going on for us from the 1930s in the immediate aftermath of the Great War. Just here, I talked about inbreeding not going backwards. 2 stud books amalgamated, the Yorkshire Coach Horse and the Cleveland Bay Horse Society amalgamated their stud books, and that decrease there was the consequence of it. But since that time, the gates have been shut and inbreeding has just carried on increasing. Eriskay pony, a much more recent breed, but again, you can see we've got this increase in inbreeding, which is getting really concerning. And in fact, I've been working closely with the Eriskay Pony Society to see what can be done about it. Okay, if you just bear with me for just a moment longer, I've talked about inbreeding, which is about how related an animal, or how related you or me are to ourselves. In other words, back through our parents and our ancestors. Each of us will be slightly inbred, and that isn't being rude, it's the fact that we often share common ancestry, you know, different tribes in our history. Kinship is slightly different, and that is, how related am I to everybody else that's in this room and has joined in this meeting? Because somewhere back in history, bet your bottom dollar, and I was saying to Mark before, that my ancestors on my mother's side trace back to Ipswich, to the Blake family, that I only today discovered were quite influential Cleveland, Suffolk horse breeders. But bet your bottom dollar that somewhere down the line, we share common relatives. And because of that, I am related in some way to each of you. And that will be our kinship. And if you measure how related I am to each of you and then average it out, we can actually come up with a coefficient of how we are related as a population in this meeting. So kinship quantifies the relationship between 2 individuals, and again, describing it in terms of genes. Do we share the same gene by identical by descent? And at a simplistic level, brothers and sisters are 50% related. Sire and filly foal are 50% related. Half siblings, 25% related. And if we look at our 2 unrelated animals again, we said that if we cross them, inbreeding, which is always given this designation of F, the inbreeding coefficient, is 0 in this generation. But as I've just said, these are 50% related. Okay. And if we cross these animals, we said before, they're 25% inbred. What actually happens is we get half of that again. So they're 75% kinship. And if we keep doing that, you can see what happens to inbreeding. Well, kinship is usually ahead of it. Okay. And as I said before, if we measure the kinship between everybody in this room, or between every Suffolk horse in our population, we can get a mean kinship. And a mean kinship is actually a really important measure of how healthy our populations are. So it's quantifying how related your horse is to the rest of the living Suffolk population. And it's a good indicator of just how healthy the population is. And animals that are, if you go back to the diagram I gave you earlier, where we had an awful lot of in the heap that were red, very few blue Smarties and very few green Smarties, animals that are carrying a lot of the red Smarties have a higher mean kinship than the ones with lower mean kinship. and the ones with lower mean kinship are the ones that are carrying the rarer genes and the ones that are at greatest risk of being lost. Right at the start, I said that the third thing that I wanted to talk about was population size. And for an individual breeder, it isn't to the fore of your mind, but as a breed society, it certainly needs to start to be on the radar. Gail, I know, heavily involved with the Rare Breed Survival Trust, and I'm sure others in the room are as well. It's something that the Rare Breed Survival Trust should be very interested in, and are very interested in terms of measuring the health of our populations of all types of livestock. But the problem is that if you just go around with a pen and paper and you count the number of animals that are walking around, it doesn't give you a true picture of how much genetic diversity you've got. It would do if we had ideal populations, but that's not what actually happens, because we're humans and we interfere with animal breeding. You know, Darwinism, animals tend not to die under the hedge because we get the vet, okay? But ideal populations will be infinitely large. They would be randomly mating. Every animal would be able to contribute to the next generation. Well, we interfere with that because we go around with 2 bricks and we geld a lot of our colts, so they can't contribute. So ideal populations, certainly in livestock breeding, don't exist. You know, we'd line them up very neatly and we would have no overlapping generations. Well, I'm sure any of you that have delved into the stud books know how hard it can be to unravel them, because generations just don't line up quite neatly. What tends to happen in the real world is we restrict the size of the population, that we actually tend to have very few stallions and a lot more dams. The family sizes are all really unequal, and we have selection pressures which are not natural selection pressures. They're influenced by our choice, the type of horse that we like, the type of stallion owner we like. You know, I might like this bloke's stallion, but I'd never go there in a million years because my great-grandfather fell out with his great-grandfather and we've never sorted out that family feud. All those sorts of pressures take us away from ideal populations and down the route of selection. And ultimately, at the end of each breeding season, the Suffolk Horse Society clicks a magic button after a lot of hair pulling and scratching, and they send information off to the Rare Breed Survival Trust, which is then sent on to DEFRA, from which, with some black magic and witchcraft, based at the moment on the number of breeding females, they assemble a watch list, and then DEFRA and FANGA report to the Food and Agriculture Organization of the United Nations on behalf of government. But in fact, what we ought to be doing is reporting effective population size, which is actually what the Food and Agriculture Organization of the United Nations asked governments to do back in 2010, because it is a really, really important parameter. And what it does is it moves away from it translates from what we've got into how much genetics we've got had that been an ideal population. In other words, how much genetics are left on the ground, and if we spread that out in an ideal way amongst animals, how big would that population be? And the most effective way of measuring it is actually through the rate of increase in inbreeding. In fact, that's the only way it should be being measured. And there's a lot of respected geneticists have said that, particularly John Williams, but all sorts of problems have got in the way, and that's why we've at the moment in a situation where we count the number of breeding females. All the indications are that as we move on into a new next generation of basic payment scheme, we move over to what they're calling ELMS, there will be incentives for breed societies to report information in such a way that effective population size can be measured properly, which it isn't at the moment. And sticking with effective population size, there's some magic numbers, and that is that for a breed to be survivable in the short term, it needs to have a population, an effective population size of over 50. And in the long term, it needs an effective population size of over 500. And I read a paper this about 6 weeks ago talking about how we might report to the Food and Agricultural Organization in the future, and this magic 500 number is being talked about again. So what we do need to do is to try and make sure that we get to at least the magic number of 50 to avoid the problems that I've talked about of inbreeding depression, and certainly to have a sustainable breed. Very quickly before we break for questions, if we look at what we're losing, I talked about a generation interval being important rather than years. But if we start off with a population of 100, an effective population size of 100, then we're losing 0.5% of genetic diversity every generation, about every 9 years for horses. If we can maintain an effective population size of 50, which is that magic number that I was talking about, we're losing 1%. So as this halves, this doubles. If we only got an effective population size of 25, we're losing 2% a generation, and so the doubling goes on, so that if you've got an effective population size of only 6, and that might not be, you know, we're not talking about 6 horses walking around breeding, we're talking about the genetic diversity equivalent to 6 horses walking around, we're losing 8% per generation. So you can think back to that extinction vortex and see how much goes down the plug hole. And the other thing that I talked about, it was important that all animals could contribute to the next generation, but that in the real world we don't do that, because we maintain a few stallions and they tend to breed to a lot of mares. Let's suppose we've got an equal number of breeding males and breeding females. We've got a population of 100, 50 of which are male and 50 are female. That gives us an effective population size, like we saw in that last diagram, of 100, and they're losing 0.5% per generation. What we're going to do is we're going to keep hold of a population of 100, but we're going to start skewing it. So let's have 25 males and 75 females. You can see that now we've got an effective population size that's reduced. It's come down by 25%. It's now only 75, and we're now losing 0.7%. And if we keep doing that, if we keep skewing things until we've still got a population of 100, but we've got 99 mares and we've only got 1 stallion, our effective population size is now 4. And what's going on? We're losing 12.5% of variation. It's all going down the plug hole in 1 generation. So it's really important that we maintain as many stallions, and we don't just license them, but we do everything we can to get them being used. And right towards the end, before we break for questions, I just want to talk about how we do measure effective population sizes, and there are systems, and probably the most familiar one is one that was organized in Germany. It's on the open web as PopRep, and in fact I've already done that analysis for Suffolk horses going right back to 2018 when I first became involved with the breed, looking at how we might manage inbreeding within the breed. And where does it tell us we are at the moment? If we look at the maximum inbreeding, there are certainly some pretty dramatic 30% inbred matings going on till fairly recently, but the big figure, sorry, I'll just jump back one if it'll let me. That trend that we saw from the Susan Blott diagram has continued. We've gone through 10% inbreeding and we're now approaching 12%. It's getting in that direction. So the trend continues. In terms of effective population size, well, the magic line in the sand is 50. Suffolk horse, in the 60s, it wasn't doing so well. It bumped on around about the 20s and then started improving. But in recent years, look what's happened. It's decreasing. And it's a trend that isn't a good one, because it was decreasing here and look where it took you. If you do nothing, it's going to go back to the same place and possibly further down the graph. So there is a problem. And I think you've probably heard enough of my voice right at the moment. What I'm going to do is just stop sharing, and I'm going to pass back across to Mark or to Jessica. I'm not sure if there are any questions have been texted in, or whether there's anybody in the room that actually wants to ask a question at that logical point.
Thank you, Andy. I think the easiest way, Jess, are there any text questions in or message questions in?
No, I don't think so. I will double check.
Then can we, if anybody has got any questions, if you want to put your hand up and we'll deal with them as they come up. John Fleming. You'll have to unmute, John.
Just click on the, that's it, click on the magic red mute.
There you go.
Can you hear me now?
I can, John. How are you?
Very well, thank you. Were we wrong as a breed society to favour our grants in previous years in favour of having more young colts used, to encourage people to use young colts?
Absolutely not, because my view, and certainly the one from trying to keep effective population size big, says that providing a colt can, I don't know quite the scheme that you're running with Suffolk, but if you look at the parallel in Cleveland Bay Horse Society, basic stallion license, under the current regulations, they've renamed them now after Brexit, but the EU Zootech regulations says unless there is a very valid genetic reason, in other words, a vet can fail the horse because it's got some clear reason that it shouldn't be bred from, as long as it can pass a basic vetting, then an animal should be allowed to be bred from. Breeders should have free choice. And it may well be that you don't keep them entire forever, but using young colts is not a bad thing. You need to think about it going forwards, but certainly using as many colts as you can is definitely worth it. And later on in the talk, and it's sort of jumping the gun a wee bit, we talk about how you might either retain colts or retain their genetic potential, because you might need to geld them, but there are ways of collecting the semen at the time that you geld them and putting that in the gene bank for the future. So no, you weren't wrong. It was a good policy.
I have got another question, but I will leave it to the end when you've explained everything.
There'll be plenty of chances. Okay. Thanks for the question. Good one.
Are there any more questions? Then Andy, I think just carry on.
I'll dive on. Yep, sure. Okay, there was a chance for a loo break if you were quick then. If we go back to sharing that, if it will play. Hopefully we're back. I'll just move this out of the way. Okay, so pedigree populations. How do we manage them? And there are a number of schools of thought, some of them from wild animal management and some from livestock breeding. And one is to divide the population up and keep them apart. And in some ways, certainly with the Cleveland Bay Horse Society, that's what happened when they sent them over to the United States. And it's sort of what happened with the Suffolks, in that they've been allowed to develop over there in their own right. You keep them apart and they will develop. If you keep the ring fence about them, you'll lose genetic diversity within them. You'll concentrate different genes, but because there's no genetic exchange, you actually end up preserving more of the overall genetic diversity. The problem comes when, for economic reasons, you want to start shipping semen, or you want to start selling animals and actually shipping them forwards and back. And that in one fell swoop throws a spanner in the works of that system, because suddenly you've got genetic exchange. And there are a number of people that quite rightly say that the most important thing for us to do with all of these breeds is to make sure there's a market for them. And if we suddenly say that there will be no overseas market, then we actually ring another knell in the death knell, another bell in the death knell of the breed. So that strategy isn't a particularly useful one if we want to maintain the market. Another very viable strategy is random mating. That's what goes on out in the wild. But in livestock breeding, it doesn't work, because we're human, because we don't leave animals to randomly mate, to kick each other to death and only mate with the strongest stallion. We don't leave animals dying underneath the hedge. You know, the closest thing that we've got to random mating in this country is probably what goes on with Chillingham cattle, a semi-wild population. but we can't maintain equine breeds like that. There are very few livestock breeds that can be maintained like that. You know, random mating would be great if we could step back as human beings, give these animals a chance to roam wild and do their own thing, and let Darwinism reign, survival of the fittest. But unfortunately, we're not in that position. So random mating gets ruled out. So we're left in a situation where we have to get a handle on inbreeding. There are pitfalls in that, and I don't know if any of you are dog breeders, but it's a real hot topic with pedigree dog breeding, is controlling inbreeding. And the Kennel Club have gone to great lengths and had a lot of help from scientists coming up with a great online system to manage inbreeding. The problem is that they haven't listened to all the science from captive wildlife breeding, which tells them that if you directly manage inbreeding, in other words, just go for the lowest inbreeding coefficient in the next generation, you get short-term benefit, but 2 generations down the road, you've suddenly left yourself with nowhere to go, because what you've done is you've mixed all the red Smarties up with the blue Smarties and you can't separate them out again. In other words, you've increased the frequency of the rare alleles, but you've also increased the frequency of the more common ones. And so 2 generations down the road, you've got a problem. 3 generations down the road, you've got a horrendous problem. And then suddenly inbreeding takes off and escalates away. And they worked that out a long time ago in wildlife breeding through computer modeling. They also know it. So that's what happens in real life, because they've got some animals that have got a very short generation interval, because they're not just dealing with mammals. And I'm really concerned, dog breeders, that they've got this super system. And if you say that a generation interval in dogs can be anything as short as 2 years, I don't think there are going to be many years down the road when suddenly the Kennel Club realize that in trying to solve a problem, they built themselves an even bigger one. So management of inbreeding is definitely important, but it's how you do it. And the way that you actually do it is not by directly managing inbreeding. You actually manage mean kinship. Because of time, I'm just going to gallop on. I've really pretty much talked about what's wrong with random mating, in that socially and legally we can't do it because we don't let animals die. So what does minimizing mean kinship do as opposed to minimizing inbreeding? What it does is it helps to reduce the rate of increase in inbreeding. It stops us crossing those red Smarties and the blue Smarties. It helps us to maintain genetic diversity. It turns off the tap and puts the plug in the bath, in the bottom of the bath, and stops it drifting away. But quite importantly, if we work out what the kinship of particular animals are to the rest of our breed, we can identify the ones that are carrying genes that are at greatest risk of being lost. And they're actually the animals, for example, with stallions, the lowest mean kinship stallions need to be the ones that we prioritize for gene banking. Similarly, if we've got very low mean kinship mares, we ought to be encouraging the owners to breed from them, and probably help provide incentives, you know, travel subsidies and things like that, to help people breed, especially in times like we've got at the moment. I keep getting poked by various people to say this is all well and good, but it's all just statistics and crunching numbers and probability. And that's true. Didn't we ought to be working this out from DNA and molecular methods? And that's also true as well. We can work out what inbreeding is by, you know, doing some pretty detailed testing now. It needs to be much more detailed than what we're doing for parentage verification. If you remember, I said we're only testing 17 markers out of 2.7 billion. But as genomics increases, we can start to move towards things away from what we call microsatellites, which is what we're testing now, to testing SNPs, short for SNPs, that's single nuclear polymorphisms. And one day, probably 3 or 4 years down the road, we might be testing parentage by that. But genomics are right. We can do parentage verification from it, and I heard that next July, when the International Society for Animal Genetics meets, it's going to start identifying which genes it will use for parentage verification going forward. So, you know, change is on its way, albeit slowly. We have got the complete genetic profile of the horse now. We know what those 2.7 billion genes are in 1 or 2 animals, and I think it costs millions of pounds to work that out for each individual animal. The price is coming down now, but I still think we're talking 4 figures to get a full genetic profile of a horse, and we certainly couldn't economically be doing that for a whole population. But using SNPs, the SNPs that I've talked about, we can work out how inbred an animal is, because we get these things called runs of homozygosity. If you remember the parentage testing that I was showing you, we get all these markers that are carrying the same allele, homozygous, MMIIKK. Well, we get those things being shown up by the SNPs, but we get long runs of them. And the longer the runs are, the more ancient the inbreeding is. But we can measure shallow inbreeding from short runs and deep inbreeding from those long runs. Interestingly, there was a paper done with thoroughbreds back in 2017 that worked out that through pedigree analysis as well as this genetic analysis of the same stud book data, where you've got stud book data that goes back at least 10 and preferably 30 generations, which is certainly what the Cleveland Bay data does, you end up getting the same results from a deep pedigree as you do from the genetic analysis. So in terms of economics, if you've got a really good resource in your stud book and you do a bit of verification as SNPs come online, you just do some random sampling now and again, and it may well be that you're doing that SNP testing anyway for parentage testing in the future. Then you can just check your level of inbreeding from molecular levels for a random sample of horses, but actually base it on the pedigree data that you've got anyway. So, armed with that pedigree, we've suddenly got another tool that we can throw into our toolbox. As horse breeders, every time we make a decision, we're using our common sense, our horseman's knowledge, our eye for a horse in looking at what sire you're going to use, what stallion you're going to take your mare to. You know, it's a bit more than has it just got 4 legs, a leg at each corner, and a nice shaped head. You know, there's quite a lot that goes on to making up a good horse. We know that. That's what we're good at. We call that the phenotype of the animal. But we can now throw something else in, and that's the genotype, understanding a bit of genetics. And that genetics comes from studying the pedigree, not just shuffling it around on the table anymore, because we run out of table. We have to go to the kitchen floor because we've gone back too many generations. And then you have to move outside onto the field or the patio on a calm day, so it's not blowing around your pieces of A4 paper as you go back to 8, 10, 16 generations. You can't go back 32 generations on paper. You know, it's the Chinese grains of rice on a chessboard scenario. You have to do it by computer. And that's what the captive wildlife were doing, and they were inventing software to work out inbreeding and mean kinships and do that by computer for all of the animals in their pedigree. And that's what I did with Cleveland Bay horses right back in the early noughties. And I came up with these provisional tables over here. This was a table for my mare Carolina Nimbus against all of the stallions globally that were licensed at the time, and it told me what the inbreeding coefficient would be of the animals that I bred and whether the stallions were of a similar mean kinship to my mare. That's developed over the years into something much more colourful and to the eye, because I don't have to look at the specific numbers here. I can just look and I can go, oh, that's a green mating. That's probably pretty good. That's a yellow mating. Yeah, not as good, but I quite like that horse. Orange. Yeah, we'll try and just steer away from that if we can do. And the red matings are the ones that the system is telling us not to use. I'm going to explain that in a bit more detail. But since 2017, we've been doing the same system for the Eriskays, and as most of you are aware, those tables have been available certainly since 2019 for Suffolk horses. If we look in a little bit more detail, and I'm not putting up a Suffolk sheet here because it's a hot potato. I've been there before. So we're going to stick with Cleveland Bay horses, but the sheets are basically the same. It's specific to a named mare. It's really important that it's specific to a breeding season, because we're not just looking at inbreeding, which never changes. An animal is born with its inbreeding coefficient, but its kinship will change as the population changes. As animals are born and animals die, and as colts are gelded without being collected from and can no longer contribute to the population. Okay, so every year we need to be able to regenerate these, and as computer software improves, it's getting much easier to do that. So we're looking at the mean kinship of mares and stallions. We're looking at the inbreeding coefficient, the co-ancestry of theoretical progeny. The Cleveland Bay sheets developed the idea of location was pretty important. Is this stallion at home or abroad? Is it in the north of the country? Is it in the south of the country? And then it developed again. We're getting information on the sheets now about, is a stallion available only by live cover, or is it available by AI? Is it available by chilled semen, etc., etc. So there's a lot of information, but it comes down to one basic system of just follow the traffic lights. If you don't want to dig down into the detail, follow the traffic lights. And we've got 4 tiers of matings. Matings to be encouraged. They're highly advantageous for the breed. Best of the rest, you know, if there really are no green matings for your mare, or if the green matings are just geographically impossible or financially impossible for whatever reason, then the next best choice is these best of the rest ones, the yellow ones. There are matings that are orange that wouldn't be the end of the world, but if we could discourage them, it would be better for the population. But then there are actually these red matings, which are ones that we don't want you doing. Okay, green ones, these ones to be encouraged. Why are these green matings so good? They're matings of animals of similar kinship. That's principle number 1. If you remember, I said we don't control inbreeding directly, or we've got nowhere to go in the future. You know, we don't leave our kids with anywhere to go to breed these animals. They've got a problem. So by breeding animals of similar mean kinship, we maintain the maximum number of possibilities of possible good matings in future generations, 2, 3, 4, 5, 6, 7, 8, 9, 10 generations down the road, by using mean kinship and breeding animals of similar mean kinship. Once we've established that bit, we then need to make sure that the inbreeding coefficient of whatever we might breed is, and for Cleveland Bays, because they're so highly inbred in the first place, we actually go down the route of making sure it's lower than the mean kinship of the mare. Cleveland Bays is a very specific case, and for a lot of breeds that aren't as highly inbred, we can actually just go on what's the average inbreeding for the breed. The problem with Cleveland Bays was if we did that, there wouldn't be many green matings for most horses. So we've had to just ease things off a bit. And that's the beauty of this system, is it's tailorable for individual breeds to make it work, but to leave choices with breeders. So we try to make sure that the inbreeding, the co-ancestry of the progeny, is lower than the average for the population. And it's at this level that suddenly you can see that we are trying to reduce inbreeding, but we've made some other decisions first before we've looked specifically at the inbreeding. What about the best of the rest then? You know, if we can't do that, we still need to try to make animals of similar mean kinship for the reasons that I've explained. We try not to cross animals that are really different in kinship. We try and keep those red Smarties and the blue Smarties separate. We accept that not always, sometimes you have to, for Cleveland Bays, breed animals that are of a higher kinship than the mare, but we try to make sure they're still lower than a magic threshold number. And for Cleveland Bays, that threshold is set at 25%. That's 24%, because 25% represents brother-sister mating. Fortunately for Suffolk's, with the electronic data we've got, we're nowhere near that, so we can actually pitch it quite a lot lower. And those are, if people can't do green matings, then for the population as a whole, those are definitely best of the rest matings. Right, now if you start to run out of choices, and you know, these are animals where we really are going down the route of bringing the red and green Smarties together. They're different kinships, quite different, and the co-ancestry is higher than both parents, but we're still keeping a cap on it. We're keeping it lower than the average for the breed. Okay, we're keeping it below that threshold. So I used to think that any foal on the ground was better than no foal. I've mellowed that now, and I think that if you could only do an orange mating, then it's probably worth doing it. But if we go further down the road, if you can only do a red mating, I would say don't do it. Wait to another year, because these matings actually harm the breed. I've shown you how they make the breed homozygous. They actually directly affect effective population size, and they directly affect bringing these rare and common genes together, and they increase the chance of deleterious traits being expressed. You know, the problem that the Fells and the Dales have got with the lethal foal syndrome, it's all come about because of an accumulation of inbreeding. And I said that there are 47,000 lethal traits hidden in amongst those 2.7 billion genes. It's going to increase the chance of some more of those that we don't fully understand yet rearing their head. So for different breeds, different levels, but for Cleveland Bays, we pitched it at 0.24, that's 24% inbred. For Eriskays, we pitched it at 18% inbred. For Suffolks, we're in the good position that they're actually similar to thoroughbreds, believe it or not, that you can pitch it at 12.5%. Just so that you can put that in a human context, a 12.5% inbred mating is the same as full cousins. And there's a really good reason we don't marry our cousins, you know, really good reason. Each year when the sheets go out, we make sure that there is a guidance sheet goes out with it. As the traffic light system's been developed, it's become a lot simpler. And those sheets have gone out on a free basis, distributed by the breed societies. And from the Cleveland Bay point of view, we've slowly developed incentives to try to get breeders to take choices that not only work for them, but that work for the breed. But as I said, mean kinship is dynamic, so the sheets will change as animals come and go. The sheets are only valid for one season. They need recalculating each year, but as computer software develops, that isn't a problem. That it's really important that breeders do register their animals in a timely way. That isn't so much a problem in the UK now because of the DEFRA legislation. You know, we're supposed to have these animals registered by the 30th of November, but for a stud book like the Cleveland Bays that maintains overseas registrations, we are maintaining the US stud book. It's sometimes quite hard for us to get the animals in a timely way, but it is important that we get that information in so that we can update what the population is and present breeders with appropriate information. So when you've got access to that sort of information, what should you be doing? What should the breed society be doing? It should be encouraging breeding from as many males and females as possible. And going back to that question that I was asked at part-time, that's the reason why it is a good idea to get colts used. You don't necessarily keep them and run them on as licensed stallions, or QA as we describe it in Cleveland Bay world, quality assured stallions. They may never become that, but certainly to give them a try and let them contribute to the generation, to the next generation. So that's getting us as close as we can to that ideal situation where every animal gets to contribute to the next generation. That helps maximize effective population size. The other thing that a breed society needs to do, and it's actually quite hard, where EU Zootech or the UK animal breeding regulations actually say that breeding choices need to remain with breeders. You know, the individual breeder is the people that are empowered to make decisions, but we need to try as breeders not to breed from a really small cluster of stallions. And to put it in the Suffolk context, I don't think Bruce is actually in with us tonight, is he? But I know Bruce reasonably well, and he's done really good at the marketing side of things for Jensen. And he did a world of good in raising the profile of the breed. The downside to that was in getting a stallion marketed really well. The opposite side of the coin, the flip side of the coin, is that in the next generation, in next year, in fact, you had, I think there were 11 foals by him, and that skews things a bit. So you need to just temper that if you can, and try not to use any one stallion or any one small group of stallions, because it affects the genetic diversity, and we effectively don't pass on the genes from the stallions that aren't being used. Yeah, as it's developed over the years, we've realised there are obstacles to everyone being able to breed green matings. If we just look at geographic distribution for area escape ponies, you see it becomes a huge problem in that, you know, they're clustered up here, and what do people down here in Derbyshire and more thinly down in the home counties do? It becomes quite a problem. Geography is an issue. Travelling distance is a real issue. We've got herds that are isolated, you know, for the area escapes, they've got a lot that are isolated in the islands themselves. And one of the things that societies can do is provide travelling grants. The Cleveland Bay Horse Society does actually help with a travelling grant. We use some of our horse betting levy board money to help provide that grant. Colt retention schemes. The Cleveland Bay Horse Society has never been particularly good at this one. I know within Highlands, for example, they have a colt retention scheme. Again, that ties in with making sure that colts do get a chance to breed. Interestingly, as science improves, I mentioned we can actually do collections from colts at the time they're gelded now, and that's worth bearing in mind. Yeah, but gene banking is a big help as well, in that because we can collect from stallions and put it on, you know, put it in cold store as well as just chilled. We can hold those genes in perpetuity. And yeah, it's a right old mouthful, but epididymal semen harvesting. So if anyone is interested, and in fact the Cleveland Bay Horse Society have got an active scheme ongoing now, where we're monitoring these colts as they come up to you know, the tail end of being 2-year-olds. When it's getting to the time that decisions have got to be made, if they can't be run on as stallions, then actually providing some subsidy so that at the time that they are cut, we don't just end up putting the testes on sandwiches or on toast, that they actually get sent off to stallion AI services, and they can harvest the semen out of the tubes. And in fact, the actual collection rate is extremely good. And in terms of cost effectiveness, it means that you can gene bank a much wider selection of male animals than having to sponsor sending an animal off to AI services, especially if it's going to be collected for overseas collection, putting it into quarantine and doing it that way. So semen harvesting from harvested testes is very effective nowadays. What we have noticed over the years is that schemes come and go. In 2004, we formally launched Sparks for Cleveland Bays, but there was some informal information going out worldwide before that, and we could actually see that by the time it got round to 2004, unfortunately PowerPoint in its power has clipped the side of this slide. That's actually 30% there, 40%. In fact, we know that at its peak, 60% of animals being foaled were fully Sparks compliant. They were green matings. It's dropped off, and it dropped off back to about 45% in leaner years. But the good bit is that we can actually show that even if not everybody does it, there is benefit. And the main benefit is actually just stopping those red matings. And simply by stopping those red matings, it helps effective population size increase. And we can look at that through the change of inbreeding. You know, we talked about how we monitor it. We need to keep inbreeding and kinship down, that it will never be zero. I talked about the American Suffolk stud book and things going backwards, the rate of change. You know, we were in negative figures. It can never be zero unless you bring in animals from outside. And that was what rang alarm bells for me when I looked at that Susan Blott research, is that I think they had the gate open. There were animals from outside must have been brought in for their inbreeding to be reduced like it was. Yeah, we don't want to be bringing things down really quickly, because it will bounce back at a greater rate than before. So we need that nice steady control of inbreeding. We know it's going to carry on increasing, but we want to get it as close to that zero as we can. So what's it done in Cleveland Bays with Sparks? Well, I showed you this graph before, if you remember. I talked about this being the amalgamation of 2 stud books, and that's why it went down here to the 1930s. But since the 1930s, it's been increasing like that, right the way through to the millennium, pretty much. But I didn't dwell on it at the time because I wanted to point it out now. But have a look at what's happened here. This is post-Sparks, and it's still increasing, but we've changed the rate of increase in inbreeding. and that's from the concerted efforts of breeders. And if we look at effective population size, this is Cleveland Bay's. I showed you Suffolk's before, and it was bouncing around about 20. Well, yep, in the 1980s, we were down in the 20s. And then we managed to start to increase it. And I said Sparks was introduced in 2004, formally. It had been informally, some information had been going out around about here. Now look what's happened. This is effective population size increasing. And it's, just wind back one, sorry about that. It's gone through that magic number of 50. And it's still improving. Okay, and in fact, I can tell you that in the most recent analysis, it's now at 98. It's nearly got to 100, and that's from the concerted efforts of breeders, the Breed Society, and incentives from the Horse Betting Levy Board to actually move things in the right direction. Yeah, so for the future of the Suffolk horse, is it in an awkward position at the moment? You know, it has been in an awkward position. I think it's really good that the Suffolk Horse Society has had Sparks guidance available for 2 seasons now, and for as long as I can, or until there's a better system that takes over, I'm more than happy, you know, under the umbrella of the Rare Breed Survival Trust, to help make that available, that the data still available. It isn't the be all and the end all, and I keep telling breeders that, you know, the law requires that breeders make decisions. And it is just another tool in the toolbox. We can't tell you how to breed horses. And Sparks won't tell you how to breed horses. You still need to make your own mind up that it's going to have a leg in each corner, that it's going to be sound, that it's going to have a good looking head, that it's going to be of the stamp and type that you like. But what, through using the genomic tool in the toolbox, you can know that the breeding that you do isn't making things worse, and hopefully is making things better, and that the genetics that are represented in your animals that you are looking after at this moment in time, that you are a custodian of, are being effectively passed into future generations, and that they're not being lost. Because as I showed you before in that parentage verification thing, you might end up with really good looking horses, but you can actually have lost genetics without even realizing it, because you can't stand there and look at the horse and know that you threw a whole load of your Smarties or your marbles down the plug hole. Within the Cleveland Bay Horse Society 2 years ago, 3 years ago, we had a big problem in that a highly inbred colt did really, really well in the show ring, and people liked the stamp of the horse, but it was highly inbred, and we ended up with a problem that it was put forward for licensing. And the law says that we can't not license it. And in fact, a highly inbred colt can go on to produce green matings, but it's about education. It's about educating breeders. And what we don't want are long chains of inbreeding, because it would be quite damaging now if that highly inbred stallion, as he is now, goes on to produce more highly inbred progeny in future years. That's when we have a problem. So we need to break those chains of long inbreeding. So that's where this tool in the toolbox and education, you know, it leaves breeders in control. It makes people aware. It avoids these highly damaging matings, and we keep hold of as many of the Smarties as we can, and we pass them on to our kids and to their grandkids. And those Smarties are the genetics of the breed. Now, we really need to make sure that we're retaining it. And we need, we need to identify animals of low kinship as well, and try to encourage people to breed from them. And in the case of low mean kinship mares, to try and breed to green matings to preferred stallions. We haven't had random mating, but we've pretty much had uncoordinated mating. Individual breeders have made their individual decisions, which are entrenched in law. There hasn't necessarily been any sort of education or coordination and a taking on board of modern science as science has developed. And that's led to this accumulation of inbreeding. That has meant we got to a situation where the Cleveland Bay horse was, and the Suffolk horse is, below the 50, that magic effective population size of a 50. And as I said, you know, the law says that breeders are the people that have got to do it, but they can only do it with the help of a breed society and information being provided. Breed societies themselves can actually get help from the Rare Breed Survival Trust. And, you know, we're measuring the watch list nowadays from the number of breeding females. I think in future things will change. It will be measured more effectively by effective population size rather than guesstimation, but we've got the tools of Sparks to do it now. We've got horse betting levy board grant money that we used to, for Cleveland Bay Horse Society, simply be giving to people for producing Cleveland Bay foals. Is that good enough anymore? Is putting any old foal on the ground enough? And I used to think any foal was better than no foal. But as I learn more, and I continue to learn more, and I continue to read and keep up the interest and follow the science, actually any old foal isn't good enough anymore. And we need to try to stop these very damaging, highly inbred matings, because they're damaging to the breed in what they might do in future generations, and they're crippling our effective population size. And I know from discussions with Mark and some feedback that I've had via Mark of what Breed Committee and Council are thinking of doing, that grants to breeders in 2021 are going to be reshaped slightly, and that things are going to start to be tailored more towards incentivizing people that do take on board the breeding guidance and start to use Sparks advice. I've talked about the Rare Breed Survival Trust and about their role for feeding back information to DEFRA and the FANGA Committee, Farm Animal Genetic Resources Committee, and in turn how FANGA reports back to the United Nations. But now might be a good time, Mark, and anybody else that's on Council Breed Committee might just want to unmute, because I kind of guess this might broaden out into a wider discussion, but I'll follow on through what I understand that Council and Breed Committee have decided on so far, in that next year mare covering grants, which you've had for a number of years, they're going to be based on similar principles, that it needs to be a registered animal, licensed stallion, whether or not the mare was successfully inseminated. But for green coverings, there's going to be a covering grant of £100. For yellow best of the rest matings, £75. For those we'd like to discourage these matings, £50. So you can see there's quite a big reduction in grant there. And that for red coverings, there's still going to be a grant, but of £25. So there's a definite incentive, if you can avoid a red mating, not to do it. You've got to bear in mind that as it stands at the moment, from the analysis of the electronic data going back to 1930, and I know the stud book goes back much further than that, but we can only analyse what's in digital format. From doing that, your inbreeding is bobbing around at about 11 and a bit % at the moment, and that I said 12.5% ought to be your threshold to work below, and that's feasible. You've got to bear in mind that Cleveland Bays are up at 22%, and that their threshold is at 24%, with 25% being father-son, father-daughter, brother-sister, sire and progeny mating, or dam and son mating. It's we're in a much worse position. So we don't provide any grants for what we call red matings, but our red matings are pitched much higher. Interestingly, if you carry that theme on through, I'll put that one in just for completeness, that there's only one grant per mare per season. But what I wanted to come to is this, which I think is quite important. It's a bold step for the society, but it's very much the right step. And that is that there will be no grants in respect of sire covering daughter, daughter covered by sire, son covering dam, or the dam covered by the son. In other words, those really are the highly inbred matings, 25%. And they're the ones that we really have to watch out for in Cleveland Bays, but you really have to watch out for them in the Suffolk Horse as well. You're in the fortunate position that your average inbreeding isn't close to this yet, with the Cleveland Bay Horse Society, our inbreeding is close to this. And it's quite interesting that if you look at other heavy horses, we know from pop rep studies that Shire horses, the average inbreeding is already at this. It's at 25%. And for Clydesdales, it's even worse. They're at 28% average inbreeding. So in many respects, with the caveat that we're only looking at electronic data going back to the 1930s, and I know that there are very similar patterns of the historic data going back to, your stud book started in the 1870s, but goes back with horses to the 1700s, as does the Cleveland Bay Horse Society. The inbreeding that we've measured is the Suffolk horse. If you measured it through genomics, I think will be higher than that 12.5%, but that's what we've got to work with at the moment. So we really need to avoid these matings to make sure that we give yourselves as much chance for the future as possible. So all of those highly inbred matings are going to become a no-no and no grant, but just bear in mind, there is nothing in the law that can stop breeders doing it. The one thing that ought to stop breeders doing it isn't necessarily the fact that you're not going to get a grant, it's knowing that they're damaging to the breed. And in terms of breeding for the future, I've put this one up on purpose because we know this is Ruby, and I'm sure you're all aware that Ruby was inseminated and successfully bred a filly foal this season by Iggy through sex semen, which was a huge leap forward. Not many people know that that actually was a Green Sparks compliant mating, because I was involved with Tallis and Rare Breed Survival Trust and with Gareth Starbuck at Nottingham Trent at the time, and they were aware of Sparks and the fact that it was early doors for Sparks for Suffolks, but we made sure that whatever went on at Stallion AI Services, it was appropriate. So it's encompassed not just the modern technology of semen sexing, but incorporated genomic choice as well to make sure this was a green mating. I've said that a lot of this relies on software, and as things develop, everyone has pointed at me and said, what happens if Andy Dell goes under a bus tomorrow? Where are we at? I'm already doing Sparks for Cleveland Bays and for Suffolks and for Eriskays, and a lot of it's done manually at the moment, but I have been working with the Rare Breed Survival Trust and with other software developers to try and take things on into the next generation, and I am working on that. And it will be incorporated into various bits of stud book software. The next generation of Sparks, it's not quite there yet, but it's very much on the cards, and I am working. Rare Breed Survival Trust as well are working quite closely with this firm Cloudlines to get a cloud-based solution, as it sounds like. The next generation of website measured, it will have the pop rep analysis built into it, and that will in turn help Rare Breed Survival Trust and DEFRA and FANGA reporting back to the United Nations. So there are benefits not just for breeders, because we can provide the breeding advice, but for Rare Breed Survival Trust and for DEFRA in how they can analyse real stud book data. Just to give you a bit of a glance of where it's looking like at the moment, if you look here, there's a traffic light scheme for, you can go online and choose the dam out of your stud book and look at, what would happen if I crossed it to this sire. You just enter the sire in and it generates the figures, and it will come up with traffic lights as well. We can look at inbreeding, we can look at mean kinship, but more importantly for a breed society, we can just press a magic button and we can export the data to pop rep and run a pop rep analysis. So there's a quick look into the future for you. It is there, things are exciting, but at the end of the day, reeling it right back in, yes, the breed society has a huge place to play, but ultimately it's individual breeders that are going to make the difference. We do it because we love these animals, and I think that I'd like to thank you for your patience of listening to me speaking about something that I've become very passionate about because of my inquisitiveness of how I ought to be breeding the horses that I breed here. And hopefully you can take on the same bit of passion and understanding that it's another tool in the toolbox, and that by adopting it, not only can you make sure you pass on as much of the genetics of the animals that you're keeping into future generations, but know that what you're doing is right for the breed into the future as well. There you go, folks. Probably.
Brilliant. Thank you, Andy.
Thank you for your patience. It went on for quite some time, but I think we got there.
Andy, I don't think there's any patience. Extremely interesting and very informative. Do you want to open it up so that I can see everybody and we may be able to take questions?
If I stop sharing, that might just help things. And I'm not sure I'm actually admin, am I?
Yeah.
Mark, I've got a question
Go on,
from somebody. What happens if you have a mare that's red with all stallions? How do we approach that?
Okay. I have never come across that scenario before with any breed that I've investigated. And that scenario would only come about if you had a breeding program that was along the lines of what the Kennel Club are doing at the moment. That's the trap that they're heading for with their eyes fully shut. And that's why a breeding program managing inbreeding through mean kinship will prevent you running into that problem. So I don't think in the real world any Suffolk breeder would have that. If 200 years down the road, the Suffolk Horse Society ran into that problem, because inbreeding will carry on accumulating. You know, I said it can never be zero, the rate of increase. Let's suppose hypothetically you did run into that problem in the future. There are a number of ways of dealing with it without opening the gate up. And the first thing that you can do is dip back into the gene bank that you've got. By gene banking now and, you know, getting stallions frozen, maybe getting embryos frozen, and as technology improves, harvesting over. You know, when a female dies at the moment, the technology isn't there, so you can freeze down ovaries or harvest oocytes. We're getting closer to that now, and at the time that becomes viable, I think it is important that we not only gene bank male gametes, we harvest and freeze down female gametes as well. So we will be able to continue breeding within our ring fence by dipping back to what genetics there were in previous generations by dipping into a gene bank. So gene banking is one way of doing it. The other way of doing it would be to say, right, let's suppose somebody pulled the plug at AI Services and at Genus and at West Kingston and the whole lot thawed out tomorrow and there was no gene bank. Then you'd have to look to what other Suffolk genetic resources are there elsewhere in the world. And logically, we know there are Suffolks out in Australasia. There are Suffolks in North America, more so than just the USA. And by that time, we would be able to understand better through genomics what admixture there's been, and we would be able to identify animals in which there'd been no admixture. So you would be able to find genuine Suffolk horse undiluted genetics overseas. It would take a lot of DNA testing to identify them, but they would probably be out there. So what I'm saying is don't totally discount Suffolk genetic resources that are overseas at the moment as a resource for the future, but I don't think it's time at the moment to dip into them. And as I showed you in that graph, I think there is certainly evidence that the gates have been open and there is admixture within the North American population. So if you do dip into it, we need to be a little bit careful. So I would, at the moment myself, advise keeping the gates shut and breeding very carefully in a Sparks type way, using the resources you've got, and that will avoid you ending up in a situation where there aren't anything but red matings for your mares. You won't end up in that situation if people follow Sparks.
Thank you, Andy. Anything else, Jess?
Do we know how many?
Not from me, but Joe's got her hand up.
Yeah. Adrian, I'll come back to you, Joe, in a minute. Adrian.
Yeah, do we know how many mares have got a really limited resource to stallions? So how many are very close to having all red or a couple of red? Is it something that we would find out, or if we had the whole Sparks list for all horses available to everyone, we'd be able to see where else to breed to try and get away from it.
Yeah, that's where we're actually, with the Cleveland Bay Horse Society, we've made the female data sheets publicly available. You can go onto the website and you can have a look at not just your mare. There's no information about who owns them, so under GDPR we're okay. But in that respect, the information's redacted. But in terms of the mare and all the stallions that you can see, and even with Cleveland Bays, where we've had to do a bit of careful tweaking to make sure that there are no mares with just red matings, that we are in that situation. The Suffolk Horse Society from day one of Sparks has had access to all of those Spark sheets, and I made sure that at the point that I was putting them, that I pitched the tiers at a place where there would be reasonable choices for the vast majority of people. In the Cleveland Bay world, where we actually have a grading up scheme, it becomes difficult, particularly for grading up mares, of where they ought to go, because they're very low kinship. And my advice to them is get individual advice. I encourage them to talk to me, and then we can talk through the sheets in detail and have a look at which of the yellow matings or which of the orange matings are actually the most advantageous and the least damaging, because it's very hard for them to find a stallion of very, very low kinship. So having the mare data available on a fairly wide basis has never caused a problem in the Cleveland Bay Horse Society. If you turn the thing on its head, it is possible to produce a list that is every mare in the living population against a single stallion or a colt. And in the Cleveland Bay world, we agreed from day one that we wouldn't do that and publish that information because of the Craig Al Jensen scenario of a very clever stallion owner going out and marketing really well and suddenly having a huge crop of foals by any one stallion. So for 15 out of the 16 years it's been running, we've never done that. I've privately produced colt-based sheets for people that were going, well, this is my clutch of mares. I can't use my old stallion anymore because they're obviously inbred to him, because I bred them. They're homebred. But I need to go out and buy a new stallion now, or find a colt to run on as a stallion. What colt should I look at? And those sheets can be quite useful for people to look at, what colt would be suitable. So I've done that on a private basis. And for this year, for the very first time, triggered by that highly inbred stallion that I talked about that had appeared really successfully in the show ring, Cleveland Bay Horse Society has decided that on balance, it's better to make publicly available the stallion-based sheets, and we're now sending them out to stallion owners, not putting them on the website, but we're sending them out to stallion owners, so that if a mare that they don't know arrives, if they're taking visiting mares, they can quickly scan through the sheet, look at that visiting mare and go, that's a red mating, and talk to the mare owner and go, are you aware of Sparks? Are you aware that, and that I would actually, it would make more sense for the breed for you not to do this mating. It's not because I don't like you. It's not because I don't like your horse or your mare. It's because it would be highly inbred. And had you thought about going to Joe Bloggs down the road, because he's only 5 miles away, he's a really nice bloke, I can give you his telephone number, and he's actually a green match to your mare, and this is the reason for it. So it's about mutual education. It's about working within the peer group to help everybody understand what's for the greater good. Okay, so there are pluses and minuses to producing stallion-based sheets. Is the Suffolk Horse Society in that situation yet? No, I don't think it is. I actually have been asked by a couple of Suffolk breeders exactly the question about colts, and I have helped them, and with Mark's knowledge, I've helped provide that data and talk them through it, but I've asked them to keep the information private and just to use it for themselves. So we can use Sparks as a really useful tool in a lot of ways, and it should hopefully avoid us ending up in the situation where there is nowhere for people to go.
I mean, from my point of view, though, I'm a stallion and a mare owner. Mm-hmm. It would be useful for me to know, because I would actively turn mares away that were at the wrong banding. It wasn't why I went into breeding these horses. You know, I've got, my mares are all different lines, so it would be something that I would be very interested in having for my own use.
Can I just say thanks for raising that? And Mark, can you hear what Adrian is saying? Because it's exactly what raised its head within Cleveland Base. You know, the information is there, and I'm sure Mark can have a discussion with you, and it may well be that at the end of that discussion, Mark decides to share that information, or you agree between you that the Suffolk Horse Society isn't at that stage yet. I'm quite happy to come in on that discussion and to help out if necessary. But yeah, I think your attitude is really positive, Adrian, really positive, and it's really constructive for the breed. Thanks.
Thanks.
I think actually on that same note, that information would be really helpful if we was able to have that, if we've own the colt and determine whether we're going to geld it or not, or try and run it on till it's 3 or 4 to collect from it before we geld it. I think that'd be really useful.
Yeah,
because I mean I should be in that situation next week when I'm going to work for a lady who's planning to have the colt gelded. But it'd be really useful if it was worth running it on for another 12 months, 18 months to collect from him before we geld him.
Yeah, perhaps if you give me your details at the end, I can help you out, have a look at that, because there are two things. At a crude level, just simply looking at the mean kinship of the colt, because if it turns out to be really low mean kinship, that in its own right there's a good reason to run it on. You know, try and avoid everything. You know, don't get it cut if it's very low mean kinship. But then even if it's a higher mean kinship animal, it doesn't mean that it's of no value for breeding, because there will be loads of green matings for the higher mean kinship animals. And having a look at the cluster of mares that might logically be around and about it, and see if it could be of use either to yourself or the people that you're in contact with, or you might know people with a different cluster of mares and go, actually, that works really well. Yeah, so happy to deal with that privately outside this meeting.
Okay, lovely. Thank you very much.
Thank you, Claire. I'm going to go to Joe, if I may.
Okay.
I'll come back to you, Fred, in a minute.
Hi, Joe.
Hi. My one concern is that the Society is still looking at giving mare grants to orange and red coverings. Why would you do that?
I'll let Mark speak to that in a moment, but if I can just say, I think there are a lot of politics involved. You know, I've sat in a lot of arguments in amongst the Cleveland Bay Horse Society, and it can tend to polarize things, and it needs a softly approach rather than just suddenly going in with a big hammer. In many ways, it needs to be a carrot rather than stick. And it may well be that down the road, that's where the society ends up. I think the most positive thing out of all of that is that there's this recognition that these really highly, you know, full sib matings or son daughter, damn son matings, they need to stop, and they need to stop today. They are absolutely categorically damaging. They need to stop. Even if it's damaging, they need to stop. They are highly damaging genetically. You know, they're raising problems for the breed sooner rather than later. And so taking incentives away from them in the first place is the logical first step. Red matings and orange matings, you know, there may be some mares for which the majority of matings, until we fine-tune things, are orange matings, and it would be a shame for them to have no incentive whatsoever, and it could turn people away. The red matings, well, that's probably, you know, having taken step number 1, that would be logical. Step number 2 is to say, right, okay, we've managed to get rid of these highly damaging matings. Now we're going to not incentivize any matings that are above our breed average. So that's step 2 probably. Mark, you might want to add to that, because obviously you were in the discussion within council and breed committee.
I think, Joe, Andy has really questioned the questions that are coming forward. We have discussed. We are taking a very softly approach. We've got to look at everybody's view. Some are strongly against the position that we have taken, but fundamentally we think the spark system is the correct way to push forward, but we didn't think it was correct to do it in one fell swoop and cut out those bottom two. And that's where we are at the moment. And going forward, we will monitor this and gradually, hopefully, in my opinion, we'll probably gradually go to getting rid of those reds and supporting it. But this is the first year where we're positively getting behind the spark system with grants. Okay.
I'll hold my tongue for now then.
Say again?
I'll hold my tongue for now then.
Fine. Thank you. Jules, I saw your hand up. I'm going to take Fred first, if I may.
Mark, thank you very much. Andy, thank you for an excellent presentation.
Thanks, Fred.
Very clear as always. Just to put things into human context, the 12.5% inbreeding that we have in the Suffolk is equivalent to first cousins, as you said.
Yep.
Those of you who are students of history will probably recall that the royal families of Europe, and in particular Queen Victoria's particular family, were quite good at breeding cousin to cousin, and that resulted in haemophilia in many of that family across Europe. So that's how close it is, and that's how a deleterious trait goes through a human population that is breeding cousin to cousin. So we're doing that with our Suffolks at the moment. Within the horse breeding fraternity and in other breeds, there is something that we're coming across in the thoroughbred, which is a gene called the FKBP6 gene, which is a gene that is affecting fertility in stallions, and it reduces the rates of fertility, not to zero, but it varies between 15-20% per cycle. That's 15 to 20% of the mares going in foal per cycle, to around 40%. So it's depressing fertility. We haven't come across that in the Suffolk yet because we've not tested for it, but we've come across it in other breeds as well. And there are also similar genes in warm bloods that are doing, it's not the identical gene, but are affecting male fertility as well. So those are things there. A question to you, Andy, how important is it that we actually complete the information, the pedigree information is the basis of sparks? It goes back further generations to have a more accurate assessment of what actually our inbreeding coefficient is. You mentioned that the Americans have done that with the American Suffolks, and they have loaded more generations into it. And should we be doing that with our stud book? And of course, our stud book goes back far further to get a more accurate assessment of inbreeding.
Yeah, I mentioned this when I came to your place last year, that at the moment we've got data that went to the 1930s, so it's taking us back probably about 10 generations, which is okay, but we know full well that the Suffolk pedigree, like the Cleveland Bay one, goes way back. It will step outside the stud book and go on potentially 30 plus. Cleveland Bays were at 36 generations now, and of course animals back at that level were related in themselves. There was a paper, it's in the Public Library of Science, so you can get to it online, in 2017, looking at Australian thoroughbreds, McGivney, and they looked at genomic inbreeding versus pedigree inbreeding, and they found that if you've got a pedigree that is robust and it goes back at least 10 generations and preferably more, and in the case of thoroughbreds theirs was going back 30 generations, there is a massive correlation between the long runs of homozygosity and the inbreeding assessed by pedigree from rate of increase in inbreeding. So I think if you can digitize your stud book further back, it will only improve the reliability of any pedigree-based breeder's guidance. And I'm actually working with Simon Cooper and Redbury and Nottingham Trent University, looking at this for thoroughbreds as well, in the opposite direction, in that they've got an awful lot of genomic data and they haven't done the pedigree analysis, and they're looking towards managing inbreeding, potentially using the same sort of system. So yes, I think it will be of value. What will it mean? It will probably mean that we have a better understanding of the true level of inbreeding within the Suffolk horse, and it will increase. It won't decrease. It will increase, and we may have to rejig the figures. Does it mean that it invalidates what we're doing now? No. Does it mean that red matings will no longer be red matings? No. It probably means that there will be a wider clutch of red matings identifiable, but it doesn't invalidate what we know now. It just makes it more robust if we can actually go back further, because we know from the parallel study in thoroughbreds that it ties in with genomic data. So in answer to your question, simple, yes, it is worth that effort, Fred.
Something to be noted, Mark.
Thanks, Fred. Jules, question.
Yes, hi. I understand your concept of keeping two separate populations for as long as you can, but when does that point come where you can no longer keep two separate populations in a sensible fashion? And leading on from that, is it not possible to use Sparks analysis on, for example, US pedigrees? Say somebody wanted to import a colt or a filly or whatever. What is to preclude that analysis being done?
Okay, good question. Thanks for that one, Jules. If we put it in the Cleveland Bay scenario, in the early days, there was a separate American Cleveland Bay stud book. It ran for 3 volumes in the very early 1900s. And then there was an amalgamation. So the Cleveland Bay Horse Society has effectively been managing that American population and acting as the main registry for it. So we have all that data. And Sparks, if you go back to the original derivation of the title, where it came from captive wildlife, was single population analysis and record keeping system. And it did that for every captive population of wildlife around the world. And it managed them not just as global populations, but also as regional populations. So you can manage it at subpopulation level. And for Cleveland Bays, we found that the population was so compromised that unless we actually just did it as one big analysis, it made no sense just to do the American population or the Australian population on their own. There's not enough diversity left in those pots. So yes, we can manage a global stud book. The problem is where you've not got full data, it's how robust is that data? If you're accepting data from somewhere else, how robust is it? And whilst we can take it at face value, just looking at that graph that we had, it rang alarm bells to me that something has gone on, that there is admixture in the population. And if that isn't accurately recorded, then we start to make judgments based on errors. And it may well be that in future, we are in a situation where we need to dip into overseas genetic resources. I think we need to be able to validate them first, Jules. So Sparks can do it, but we need to make sure that the data that we're bringing into a global analysis is valid. That's the big concern. So it's how true is the data?
Yeah, you could say that of any stud book, because you're relying on the fact that everybody who has ever entered data into a stud book is doing it on a genuine basis. And we all know that is not that. Basically, any breed of horse is purely a man-made effort.
Exactly.
To get something that looks like the breed standard. Reference, but it still applies to horses. I find it hard to actually think that it's a good thing to take issue with something that on a blip on a graph some 30 years ago to affect what we're doing now. I mean, we have eyes. As any livestock breeder will tell you, if it looks like a Suffolk, has a DNA analysis of a Suffolk, why isn't it a Suffolk? It's just the fact that you have 2 separate stud books by 2 different sets of people. It seems to me like you're making it rather more complicated than it needs to be.
And what I'm saying is there is a resource over there. And the Cleveland Bay Horse Society was in a situation where there already was exchange, and it made sense to manage it as one global population. Looking at the data and the analysis that, not me, but that Susan Blott did, you can look at that graph, and it wasn't just a blip, it was a definite downturn over a substantial number of years, which goes, this isn't just one horse, there's something going on here. You know, how have they been managing this stud book? Have they altered the breed standard? Have they got a grading scheme going on? What's going on? I don't know, because I don't know the stud book that intimately. So we're not just talking about, there's something that's gone on. Yeah, there's something been going on.
Yeah, they did have a grading scheme. We have a grading up scheme here still going on. It's called the International Register. Whichever way you look at it. I think the big fault on the Spark system, and I'm going to have to say this, is not every breeding filly or mare in the UK is on that register, mainly because some of them are registered with the, well, now the NASHA, but ASHA in the States. So you're missing a population, probably in the region of 20 to 30 females in this country.
Okay. And there's a similar situation
with this this determination not to recognise reciprocal stud books.
Right. Okay. If I can pick up on the first thing, is the data is only as, the analysis is only as good as the data in it. And if people have chosen to register in another registry, then there is nothing much that the people that are conducting the analysis can do if they don't know about those animals. So that's a registry matter. In putting it in the Cleveland Bay context, for political reasons, the Cleveland Bay Horse Society of North America fell out with the Cleveland Bay Horse Society in the UK about 10 years ago, and an independent Cleveland Bay Horse Registry, using the Texas A&M University to do the DNA verification, raised its head. And for a number of years, there was a significant proportion of the North American population wasn't getting registered in the Cleveland Bay stud book. And then we had a change of council, because it was all about politics and faces that didn't fit. We had a change in council, and we actually had a policy where, partly because quite a substantial proportion of the Cleveland Bay Horse Society membership is in North America, and recognizing that because of the way that horse betting levy board money is allocated, we couldn't give grants to overseas breeders, particularly North American ones, from our own monies, from the Queen's Fund that came from the Windsor Horse Festival. We said that, right, in lieu of horse betting levy board grants, we will give free registration to horses in North America, providing they send in the hair samples and we do the DNA verification. And so we've had a catch-up game, and I think we've now swept in 25 horses on that free registration scheme. So what I'm saying is, I am in full agreement with what you're saying. We should be looking at it holistically, and in the ideal world, if you could take the human aspect out of it, there is merit in managing as one stud book, and in recognizing there are genetic resources overseas that are a genetic resource for the breed. But given the complications at the moment and the politics that are involved and the number of different opinions that there are, we're probably in a situation where we shouldn't open the gates up at this moment in time until things are better understood and people. Now, it's the slowly process. So yes, I agree with a lot of what you're saying, and we do have to challenge the validity of stud books, because, you know, in the Cleveland Bay stud book, we know there is nonsense that went on, but we are where we are, and genomics will help us to understand that better. Fred's got his hand up.
Thank you. Yes, Fred.
What I'm led to believe is that the American stud book parentage verification predates that of parentage verification in this country. So the records go back earlier than what we have here, parent verified ones. Has that been taken into account in your studies or in the analysis? And secondly, what is with the use of mitochondrial DNA? How accurately can one verify historically the identity of an individual?
Yeah. Okay. So let's the mitochondrial DNA to begin with, just to broaden that one out for the benefit of other people. If you're not aware, mitochondrial DNA is only inherited down the dam side. So if you're looking at a pedigree, a mare and a colt will inherit mitochondrial DNA from its dam. So it's only passed down a tiny part of the pedigree. And if you draw back the pedigree 8, 10, 12 generations, it's a tiny part of the baseline. So maternal inheritance is interesting, and breeds do get divided up by it, but it's like this idea of bloodlines. You know, what's the sire line? And I'm pretty sure that just like with Cleveland Bays, which can all be traced back down the sire line, and has been verified now with Y chromosome studies, that they all go back to one horse, that's Skyrocket, who then goes back to a Turkoman horse. And on the Suffolk side, is it Crisp's horse that they all go back to? I think there's one active sire line. There's an awful lot of other genetics in there as well. So mitochondrial DNA on its own won't sort that one out. But I think what will be much more powerful tool to sort it out, which we can't sort out with microsatellites at the moment, is when SNPs, when SNPs come on board, we will get a much more accurate profile. And then we will be able to see admixture. It will shine through. So I think we're not far off down the road for getting to a point where we can do that. In terms of have we taken into account how far back parentage verification goes in any of these stud book analysis? No, we've had to take the stud book at face value, and we have to accept what Jules was saying. You know, stud books are historically inaccurate. It may well be that in 3, 4 or 5 years time, when we're able to do parentage verification using SNPs, that some of these dark horses and skeletons do start falling out of the cupboard.
Fred.
You're muted, Fred.
Just one more thing, completely aside for just a practicality. We were talking about epididymal semen for freezing. Now that is very useful. Works, can be done. It's relatively straightforward flushing. It's a bit finicky, but it's relatively straightforward to flush the epididymes from testes that have been removed from a colt. When you do that, it has the best thing, or the easiest way of doing it, is actually putting the testes in a cool box and sending them off either up to a center that can do this, be that Stallion AI or other places. But it's only worth doing in colts that are at least 18 months of age. The stallion or the colt matures, reach a sexual maturity or produces viable sperm at roughly about 14 months of age. So you want them to be at least 18 months of age. There's no point taking it off weanlings if you're castrating foals or weanlings. It's got to be an older, at least 18 months of age if you want to do that, preferably a bit older to get the volumes of semen that you need to freeze.
Yeah, that's a really good point, Fred. And Tallis has been producing some guidance notes for Cleveland Bay Horse Society. I think it'll be well worth sharing with yourselves as well. You know, and it will be worth you contributing to that as well, Fred. You know, there's a lot of stuff that breed societies can share as technology improves, and that's really valid. And I think we had one that was cut at 28 months old, and the count was really high. You know, really viable semen.
The other thing about, you mentioned eggs earlier on.
Yeah, oocytes, yeah.
Oocytes can now be collected from the mare standing. It's a standing procedure. It's becoming more and more successful. You can put a needle into the ovary, into the follicle, and suck out the eggs from there. It is still not a day-to-day procedure, but it can be done, and it is being done. And then those eggs are then sent off to a center in Europe, in Italy at the moment, where they are then where then a sperm cell is injected into the egg. It's called ICSI, and embryos are then produced. And those embryos, as technology is improving, can be frozen with a greater and greater success rates. and kept like frozen semen for well, 1,000 years probably. The oldest frozen semen I ever used was over 25 years old. So we know that will be the similar thing with embryos as well.
Yeah, just to flesh that one out a bit, Fred, I was at a National Pony Breeders seminar last year, and the great and the good were there. Tallis was there, all sorts of the right people there at the right time. And overnight, the a mare that was on loan, and I'm just being a bit guarded here into telling you who it was on loan to, but yeah, a mare that was on loan to a very prestigious person died of grass sickness. It was put down, and both were involved in this as well. That the oocytes were harvested from the dead mare and were got off to Italy. The procedure can't be done in this country at the moment. Using sparks, we were able to look at a green mating using semen from the gene bank that Rare Breed Survival Trust were in control of, and they identified the stallion. It was a stallion called Tregoy Journeyman, which was held at Stallion AI, and Tallis was able to pick up the phone and get that semen shipped over to Italy. In fact, at one point, Tallis was about to jump in his Porsche, go and grab it and go and get the oocytes from Beaufort as well, and drive them out to Italy overnight, but they did manage to fly them out. We had to check with DEFRA about licensing all of this, because the semen had been collected and was effectively quarantined and licensed for use in Europe. They approved as long as the embryos, any embryos resulting from that ICSI process, returned to this country and weren't kept stored in Italy. And there are now 3 viable embryos out of, they managed to get 7 originally. 3 went on enough to become viable, and they're now held frozen at Beaufort. But I know Tallis is keen to develop technology at Stallion AI so that they potentially could become the first centre in the UK where that could happen. But it's a case of, if you've got a low kinship mare who suddenly has to be put down, just being aware of all this technology. Unfortunately, it wasn't cheap, but fortunately the person who the mare was on loan to was in a position to be able to say, I will fund this. And to their credit, they actually donated the embryos back to the mare owner, and the mare owner now owns them. So there are a number of issues, cost being a huge one, but fortunately for that mare, she was on the loan to the right person. And it's, although the event has the fact that it appeared in Horse and Hound, but the person who funded all of this asked very specifically not to be named. So yeah, technology is wonderful. Yeah.
I'm going to take one more question, and that's Sue, before I round it up, please. Sue, you're on mute, Sue.
Yeah, following on from that question about harvesting oocytes, is it worth the Suffolk Horse Society identifying the most rare, lowest mean kinship mares and approaching those mares to see if they would, and possibly the society funding or part funding, harvesting from those particular mares for the future?
If money was no object, I would say yes. Unfortunately, money is an object, and you've got to do stuff that's cost effective and cut your cloth to fit. In terms of using the information, what we did, the Cleveland Bay Horse Society did many years ago, was ran a selected mating scheme. And that, as in outside of the annual grant from the Horse Betting Levy Board, they put in a separate bid for a selected mating scheme that identified green matings for the lowest kinship mares, and had incentivized grants in addition to the routine Horse Betting Levy Board grants made available. And out of the crop of foals that we got, 3 colts went on to be licensed stallions in their own right. And of course, because they're low kinship, they're actually really useful for low kinship mares. So the fact that we've got them around and about now is because of that selective mating scheme. So whilst further down the road, it might be that society wants to invest its money in an oocyte collecting scheme. I think it might be more effectively used at this moment in time, being not quite as ambitious and being more practical on the ground, with encouraging, you know, mare owners that have got these low mean kinship mares just to go out and breed properly from them at this moment in time. The other thing that Fred didn't mention was tissue punching, and ethically we're not allowed to do it from living animals, but the Cleveland Bay Horse Society has just started a scheme where if an animal is euthanized, or if it just dies through natural causes, as long as you do it early enough, if you take an ear off, shave it, and then get it off to Stallion AI, they can then tissue punch. And the technology isn't there at the moment to do anything with that tissue, but it's preserving genetics, and who knows what we can do with that in terms of cloning 20, 40, 50 years down the road. So tissue punching is actually very cost effective. There's no quarantining involved.
Can I just ask a second question about, you talked about a stallion that's been used quite considerably. What is there to disincentivize these stallion owners from blanket covering lots and lots of mares? Is there anything in the grant scheme that, or would you suggest that something in the grant scheme should be, right, okay, you get a full grant for 5 mares and then it's a sliding scale to disincentivize the overuse of stallions?
That is there. That's already there.
Yeah, it's
okay. Thank you.
You have to be quite creative in how you do that to make sure that what you end up doing is not illegal because of the EU ZooTech regulations. But yeah, you do need to make sure that you don't suddenly end up dishing out a whole pot of money to somebody that's doing something quite harmful.
Yeah, the grant does drop after 10. Okay.
After 10?
Yes.
10 is quite a lot if you consider that we've only had 25, 30 foals born. That's a third of the...
That's not a year. That's not a year.
Oh, okay.
Yeah.
Okay.
Just to put that in a worldwide context, I was in a meeting with Simon Cooper from Weatherby's, and the hot potato at the moment in America is that they are now bringing in a rule that no stallion can cover more than 140 mares in a year. Fred's nodding his head. That's right, isn't it, Fred? It's 140 mares a year. That's the North American stud book. So that's quite a hot potato, because obviously it's a big commercial industry, and that's going to cut someone's income. And there's the thoroughbred breeders at home and elsewhere are looking at that one and getting quite worried about how you do that, how you deal with that. Yeah.
Okay, I'm going to draw the evening to a close. I think, Andy, you've done remarkably well, just over 2 hours, and the level of questions has been fantastic. Thank you for giving up your time. Really interesting talk, and thank you for all the support you've given Suffolk Horse Society over the last few years, and indeed myself over the last few months. Really appreciate your time, and thank you everybody for joining us.
Mark.
And I'm glad you were able to join us, and thank you for setting this all up. Jess.
I was just going to say, if anyone does still have any questions, please send us an email tomorrow and we will make sure that they're answered for you.
Yeah, there were 1 or 2 people that I said I would deal with something off camera, and so perhaps the best way to do that is to fill that back via Jess and get the information to me, and then Jess will put you in touch.
Yeah, that would be great.
Thank you very much.
Thank you, everybody, and keep well. Talk to you soon.
Thanks for inviting me into your homes.
Thank you, Andy.
Andy, bye-bye.
Bye-bye.